After studying this module, you will be able to know about environmental economics, understand the importance of environment in economics, analyze the utility function within environmental good, understand Pareto frontier and efficiency.
Untreated sewerage waste drained into the river with pollute scarce water resources which may affect the availability of the drinking water, aquatic life and many more. A factory situated near a laundry shop polluted all air will affect the, the laundrables products of clean listen. A brick manufacturing unit near a mango farm will badly affect the quality of the mango. All these examples illustrate the type of problems we consider in environmental economics. They have both positive and normative aspects of study.
The nature has gifted us a variety of renewable and non renewable resources. These scarce resources can't satisfy all of our unlimited wants, but the efficient use of resources may provide all the necessities for present and future generations. The type of problems that we consider in environmental economics can be illustrated with the help of examples. Untreated sewerage waste drained into the river will pollute it, which may further affect the availability of drinking water, aquatic life, and many more. A factory situated near a laundry shop dirtying the air will affect the launderer's production of clean linen. A brick manufacturing unit near a mango farm will badly affect the quality of mangoes. Environmental economics have both positive and normative aspects of study. From a positive point of our area of interest may be to understand how the existing structure of institutions will lead the self-interested factory owner, the institution responsible for the management of sewerage system, and the owner of brick manufacturing unit to undertake an action against their harmful impact on others. From a normative perspective, one might be interested in suggesting policy interference for mitigation of these harmful consequences. Origin of environmental economics is related with the concept of market failure. Repairing of market failure needs government intervention. Policy interference by the government needs the suggestions from environmental economists. Now we understand the importance of environment for the economy. Our economic system provides us the desired material goods and services for all our needs. This economic system can't survive without the support of environment around us, which includes various communities of insects, plants, animals, and different other natural resources. The interrelationship and influence in a community of organisms and natural resources on each other is called an ecosystem. The environment provides us the raw materials which are transformed into numerous commodities through various economic processes. Simultaneously, it also provides direct services to all of us by providing oxygen, air, water, sunlight, scenic beauty, etc. The uninterrupted supply of these environmental goods and services is necessary for the existence of our economic system. The basic economic processes of extraction, for example, mining of iron ore from iron mines, processing, fabrication, converting the iron ore into steel and automobile, and consumption using the automobile all involve the generation of waste product that ultimately goes back into the environment, air, water, or onto the land. The economic models try to solve the problems of finding the efficient and right amount of production and consumption in terms of minimization of costs directly involved in the process of production and maximization of utilities in the consumption of market goods. But they do not try to find the right or of socially desirable amount of waste or the pollution. Our environment also acts upon the waste being produced by us. This natural process helps to clean up and recycle the waste to be used again. But there is a capacity of nature to absorb the waste or the pollution. If the pollution crosses this capacity, it starts affecting the producers as well as consumers by affecting the supply of environmental goods. As for the survival of present generations, the production of market goods is necessary. Similarly, for future generations, the protection of environment is also necessary. Hence, in environmental economics, an important question is to find the right balance between protection and use of environment. To understand the utility function with environmental good, we first have to understand that the basic nature of a market good is different from an environmental good. Market goods are rival and excludable in nature, while environment goods, which are pure public goods, are non rival and non excludable. If bread, a market good, is consumed by one person, the same can't be consumed simultaneously by another person. But the decrease in air pollution or the provision for clean water, an environmental good, in a particular area by controlling the industrial waste disposal will be enjoyed simultaneously by all the people of that area. Hence, the total utility of a person will depend upon all the market goods consumed by him and the utility from environmental goods available for everyone. Now, if we produce more of market goods, it will be associated with more production of waste, hence, there will be less of environmental protection. Thus, the utility of a person will depend on both market goods consumed by him and the environmental goods. Hence, his total utility will be Ui xi, where xi represents all the market goods consumed by him during a period of time, and E represents the environmental quality during the same time period. Different people may consume different quantity of market goods but must consume the same amount of environmental quality as it is a pure public good. Let's now understand this with the help of a diagram. In the figure, x-axis represents the market good denoted by x and the y-axis represents the environmental good denoted by E. Any improvement in environmental quality means higher value for E and vice versa. U1, U2, U3, U4 shows a set of indifference curves with composite market goods and environmental goods. At low levels of X, environment is less valuable, hence, a loss of utility because of a small decrease in X will be offset by a large quantity of E. But as we move to higher values of X, a smaller quantity of E will be required to offset the same quantity of composite market good X. Thus, higher indifference curves represent higher level of utility. When the consumption of market goods increases, the consumer values more to the environmental good where he is ready to give up X3, X4 units of market good for a small quantity of E as compared to lower indifference curves where he will be ready to give up the same quantity of market goods only for higher quantity of E. Next, we assume that there are n individuals in the society. Then, a societal consumption bundle will include all the market goods consumed by each individual separately and the environmental good consumed collectively. If A represents a societal bundle such that A is equal to x1, x2, x3 till xn E, where x1 composite market goods consumed by individual 1, similarly x2 by consumer 2, and so on. E is environmental good collectively consumed by all. Similarly, another societal consumption bundle A dash will be represented by A dash is equal to x dash 1, x dash 2 till x dash n E dash. Each individual is facing a trade off between market goods and environmental goods. Their utility depends upon both X and E. If the utility of market goods UX increases, then utility of environmental goods UE decreases as higher production of market goods is associated with lower environmental quality. Hence, to maximize the utility, each individual has to find the right balance between X and E. Poor people will value market goods more than the environmental goods as they will be on lower indifference curve, while the rich, who are on the higher indifference curve, will be more concerned for environment than the poor. But when the people are facing the trade off between market goods and the environmental goods, the collective decision making for the whole society becomes more difficult and complicated. The individual can choose about her consumption of market goods only. She may decide to help in protecting the environment but can't decide a different consumption level of environmental goods for herself as compared to other people around her. A redistribution of market goods among the people of a society is possible by changing their relative prices, but the same is not possible for environmental goods. We may increase or decrease the quantity of environmental goods by changing the production of market goods. The same quantity of environmental good may have different utility for different individuals depending upon their income level, philosophical thoughts, level of information, education, etc. Now, assume that different levels of market goods being produced are X dash, X double dash, etc. for the society as a whole, then the associated levels of environmental goods for the society are E dash, E double dash, etc. respectively. Now the societal consumption bundles may be represented as A dash is equal to X dash, E dash, A double dash is equal to X double dash, E double dash, and so on. When X dash quantity of market goods is being produced, all the end consumers will be consuming x1 dash, x2 dash, xn dash respectively. Similarly, for x double dash quantity of market goods, they will be consuming x1 double dash, x2 double dash till xn double dash respectively. Next, we face the question of societal choice, that is, which consumption bundle should society choose, A dash or A double dash, if there are only two societal bundles. If every individual prefers A dash over A double dash, the society will also prefer A dash over A double dash. Similarly, even if every individual, except one who prefers A dash over A double dash, equally prefers A dash and A double dash, society will also prefer A dash over A double dash. In both of these two cases, there is no controversy. We can say that A dash is Pareto preferred to A double dash if we use Pareto optimality criterion. The Pareto optimality criterion states that an economic outcome is said to be Pareto optimal if any reallocation of resources can't make someone better off without making another worse off. This can be stated as explanation 1, which says that for a group of people consisting of n members, I is equal to 1, 2 till n, with their respective utility function ui decided by their consumption bundles, assume we have two societal consumption bundles, A dash is equal to X dash E dash and A double dash is equal to X double dash E double dash, then A dash is Pareto preferred to A double dash for the whole group if for every individual ui A dash is greater than or equal to ui A double dash, and at least for one individual ui A dash is greater than ui A double dash. Next, suppose a society consists of only two individuals, Anish, whose utility is represented on x-axis, and Bina, whose utility is represented on y-axis. Their respective utilities are represented by UA XAE and UB XBE. The figure shows their possible utility combinations in the utility space with limited available resources. The attainable utility combinations lie either on or below the utility possibility frontier AB. Now let's compare 2 points G and H. Utilities of both is higher at point H as compared to point G. Hence, H is Pareto preferred to G. Similarly, F is also Pareto preferred to G as Anish's utility remains unchanged, but Bina's utility increases when we move from point G to point F. While comparing points K and H, we can't conclude that one point is Pareto preferred as compared to another point. To make Anish better off, we have to make Bina worse off, or to make Bina better off, we have to make Anish worse off. There will not be a unanimous choice between points K and H for Bina and Anish, but the unanimity is possible between both of them while comparing points G and H or G and F. Further, we discussed the feasibility of Pareto improvement with compensation for the society with help of a diagram. We extend the two members, example n members of the society. Moving from point G to K will be acceptable for Anish but not for Bina. Bina may accept only if she is being compensated by Anish, and that compensation should be able to offset her loss of utility while shifting from point G to K. This compensation is possible only through market goods, as environmental goods can't be exchanged between two consumers. As shown in the figure, The shaded area of triangle FGL shows all the points which are Pareto preferred to point G, but we can't say for other points which are lying outside this triangle in attainable area. Comparing a shift from point G to K, the gain of utility for Anish is change in UA, and the loss of utility for Bina is change in UB. If Anish compensates Bina by giving her Y units of market goods, then both will agree only when, for Anish, change in UA is greater than or equal to UAY, and for Bina, the change in UB is less than or equal to UBY. In case when compensation can make unanimity among the individuals for a particular societal bundle, we may say that there is feasibility for Pareto improvement. In our example of point G and K, Bina, who was a loser, got compensated from Anish, and both agreed for this compensation of Y goods. We may say that K is potential Pareto improvement to G. This same example may be generalized for n number of people in societal group. Thus, it can be stated as explanation 2, which says that for a group of people consisting of n members, I is equal to 1, 2 till n, while comparing two societal bundles A dash and A double dash, if there exists a vector of transfers from individuals such that the sum total of all the transfers is 0, y is equal to y1, y2 till yn. Sigma yi is equal to 0 and a dash y is equal to x dash 1 plus y1 x dash 2 plus y2 till x dash n plus yn e dash becomes Pareto preferred to a double dash. Then we can say that a dash is a potential Pareto improvement over a double dash. With a large number of people in the society, the feasibility of implementation of Pareto improvement criterion becomes very difficult. Nicholas Kaldor and John Hicks have suggested an alternative in Kaldor-Hicks compensation criterion. Suppose that the government wants to install sewage treatment plant. Some people will gain because of the availability of clean water, while a few will lose because of bad smell in their surroundings. According to this compensation criterion, if government asks the gainer whether they are ready to compensate the losers and their answer is yes, then building of this plant is Pareto improvement. Hence, good idea for the society. Let's now understand how to move from individual utility to social welfare function. We draw the societal utility function, which is also known as Bergson-Samuelson social welfare function or the social welfare function. Each societal bundle, say A dash or A double dash, represent the consumption bundle of all the individuals. For example, if a social welfare function is represented by a societal bundle A dash and at A dash 100 units of market goods and a certain level of pollution is available, from these 100 units of market goods, if Anish is consuming 60 units and Bina is consuming 40 units, then their utilities at point A dash will be determined by their consumption of market goods and environmental goods. Anish's utility at point A dash will depend upon 60 units of market goods and dash E double dash units of environmental goods. Similarly, Bina's utility will depend upon 40 units of market goods and dash E double dash units of environmental good. The total social welfare at point A dash will be determined by the individual utilities of all the members of the society, which are Anish and Bina in our example. Hence, social welfare function W at point A dash may be written as W is equal to W UA A dash UB A dash, and if there are n members, so that I is equal to 1, 2 till n, then W is equal to W U1 A dash till UN A dash. If in comparing two consumption bundles A dash and A double dash, utility of all the individuals is greater at point A dash as compared to A double dash, we may write W U1 A dash till UN A dash is greater than W U1 A double dash till UN A double dash. Then we can say that A dash is socially preferred to A double dash, where W is Bergson-Samuelson social welfare function. If a social welfare function exists to show social preferences, we can also draw social indifference curves. The figure shows such social indifference curves, which are just like individual indifference curves. Point A dash is Pareto preferred to A double dash and also represents higher level of social welfare. Point C is not Pareto preferred to A double dash but is on higher social welfare function, hence represent higher social welfare as compared to A double dash. We will now discuss about Pareto frontier and efficiency. Consider the two-member society. We have already discussed that the attainable area lies on or below the curve AB. We can see that because the point G lies below the utility possibility curve AB, there exists the points like F, L, and all other points on curve between F and L which are Pareto preferred to G. At point F, Bina's utility increases without decreasing Anish's utility, and at point L, Anish's utility increases without decreasing Bina's utility, and on all the points between F and L, utility of both is increasing. Similarly, for all the points below the curve AB, there is a possibility of Pareto improvement. But for all the points on this curve AB, we can't increase the utility of either Anish or of Bina without decreasing the utility of others. When the Pareto improvement is not possible, the point becomes Pareto optimal. Hence, all the points on curve AB are Pareto optimum. That is why we may call this curve as Pareto frontier. We may consider an allocation to be inefficient if any improvement over that is possible. Point G is inefficient as improvement in allocation is possible. Point F and L are not inefficient as any improvement in Pareto sense is not possible over these points. Generalizing this to all the points of Pareto frontier, we may say that all the allocations on Pareto frontier are efficient or Pareto optimal and the allocations below the Pareto frontier are inefficient.